basically the different countries can download that tool to put in their country-specific environment, well, settings like how many people there are, how many people get tested positive on a certain day, and so on. And the tool then will basically forecast the required material, like gloves or mask or just safety material, so that the countries can basically order the right amount of masks, for example, to be able to fight this pandemic. And needless to say, that tool is provided as an Excel workbook. And I think it's probably well, a typical use case why Excel is still around. So sometimes the pandemic, has arrived quickly. It doesn't wait for an IT system to be provided and caught up with the current situations. So you need to deliver something quickly. And also the people who know how to calculate, the right amount of masks and other protective tools, they may not be like close enough to IT to be able to quickly deliver a tool which you can use to forecast these things. And so that's kind of why Excel is still a topic today. And you can also see, like, from the name that they're using, V2 for version 2 plus an updated timestamp here, that version control, as we know it from a developer's perspective, is very much an issue with Excel files. And so from this, motivating example of the current times, I'm showing this again as a tweet that I saw a couple of years back, which kind of really pretty much summarizes the issue with Excel files, or one of the issue with Excel files pretty neatly, which is just like the missing version control. And it's pretty much exactly using the same principle as the World Health Organization tool from the slide before was using. So it's very easy to get confused about that. So definitely one of the issues that Excel has. Now, another issue that Excel has is the complexity of formulas. So that, again, is a formula I took out directly from that COVID-19 forecasting tool. And I personally have no idea what is happening in that formula, and probably nobody has until, unless it was you who was writing this formula, probably personally. And the issue is it's unstructured. You don't know what the column names refer to. So it's very, very hard for somebody else to kind of validate or peer review these formulas. And that's another tool, another issue that Excel files generally have. And so all of these issues usually can, mean a big risk for your organization. So basically, in the case of the COVID-19 essential supplies tool, you can even look at it, it's a risk in terms of life and death. So like if a certain country uses this Excel tool and, there is an error in that Excel spreadsheet, then your country may not have enough masks and other tools available for maybe the next wave of the pandemic. And that's not a good thing. And so, in terms of cases in the past of what we could see in the news, one case I have selected here is called the London Whale, which was probably one of the biggest cases when things went south with Excel over the last couple of years. And that was when JP Morgan had I believe, $6 billion loss, which was partly, attributed to some spreadsheet coding errors. So that's kind of what we deal with while we use Excel nowadays, what the issues are, and kind of what the outcomes can be in a worst case scenario. And so we, in my company, we just look at Excel as being just another platform of just another programming language, a platform where you write code. And so when you start, looking at Excel in that way and try to apply the developers' best practices, then all of a sudden you will have much less of an issue with Excel than you have when you just, treat it as a normal business users who don't know about such best practices in programming. And the other point that we kind of, after years of working with these companies, kind of found out is a lot of the management, like many managers in a company, they would love to tackle the problem by basically just getting rid of Excel. And sometimes that is indeed an option. And we have helped smaller companies to do the migration from Excel only to like a Jupyter Notebook Python based setup. And that absolutely can work. But usually if the company is a bit bigger, or if you have a lot of complicated Excel workbooks, then it's not something that can happen from today to tomorrow. And it usually consumes quite considerable amounts of resources. So it can be an expensive thing to do. And lastly, it may not be always possible, because maybe like in the case with COVID, the reality is just evolving so fast and so quickly that a productive web application maybe just cannot, catch up quickly enough with reality. And so that's why we probably will have to deal with Excel on the business side for a couple of years to come. And that's why we like to provide tools and see how we can, simplify and make work more solid by mixing it with Python. And this is basically the next topic. So giving you a quick overview here of what options we have in terms of working with Excel from Python. And we have basically two main options here. And the one on the left-hand side is using a reader or a writer library. And that means this basically replaces your installation of Excel altogether. So you can use any of these packages to read and write a file directly, and you can do that anywhere where Python works without having to install Excel. And that's very, very powerful. And the unfortunate thing is that the state of these packages is a bit of a jungle. So you have, for example, OpenPyXL, which can read and write the modern Excel format. You have XLSX Writer, which can only write the modern Excel format. Then you have XLWT, XLRD, which can write and read the old XLS format from back in the days. And then only since recently, you also do have a package which is called PyXLSB, which also knows how to read the binary XLSB file. And currently, you do not have a package which would be able to write an XLSB format. So there are some missing functionality here on the side of the reader and writer libraries. Now, on the other hand, we have the automation libraries, and there we have XLWings, which is my creation, and then you have another package which is called Pixel. Pixel is commercial only, and as I said initially, XLWings is mostly open source. And what they do, as opposed to what we see on the left-hand side, is they interact with a running instance of an Excel application, and therefore can pretty much do anything that Excel can do. But the caveat is, of course, XLWings only works where Excel works, which means it works on Mac and it works on Windows, but it doesn't work on Linux machines, which makes it harder to use for automated tasks, let's say on your Linux web server. Nevertheless, both packages are very interesting for their particular use case. And this brings me to basically the demo. And I have prepared a couple of different cases, so you can meet different packages and also see how you can treat Excel in basically much the same way as programmers treat coding. So we're going to have a look here at the beginning into like how we can use those packages to perform unit tests on Excel workbooks. So often what I see, like if an IT person is responsible for taking over an Excel tool, an Excel workbook, or is consulting a company that relies on Excel, then the first thing that they are looking for, having a developer's background, is kind of, how can I use developer's tool on Excel to make it safer and easier for everybody to consume. So that's at the beginning, and then the second half will be some samples to demonstrate a bit how you can use Excel Wings and how the interaction between Python and an Excel works. But we will start now with the first sample, which is really just kind of getting a feel for the reader and writer packages as opposed to the interaction with Excel Wings. And to do this, I am going to share my screen. And I need to pick the right one. All right. So I believe that should be working right now. And yeah, we will see, like if I manage to get through all the different demos in the time that is left. If not, I have all of the samples on GitHub, and I'm sure you will be able to get the link and be able to look at them for yourself in case we don't manage to get through all the samples. So I have prepared a notebook here, which imports basically Pandas. And Pandas is obviously the data scientist's best friend. And it has some read Excel and to Excel functions, which kind of take away the plethora of different Excel reader and writer packages. So Pandas does the selection for you, and you only have to say what you want to do. So if you want to read an Excel file, or if you want to write to an Excel file. And so in that case, you can see I'm just doing read Excel file. I have my Apple stock market equity returns, like stock prices down here, and that's all you need to do. So behind the scenes, Pandas then basically uses XLRD to read out the file and provide you with those values. And sometimes, as you can see, it's a bit of an issue. Like if you use the Jupyter Notebook and want to look, want to get a feeling for the data, because well, it kind of leaves the data in the middle out, and sometimes it's just good to have well, good old Excel to scroll through your data. So what you could do is, I mean, obviously in that case, you could look at the original Excel file, but let's imagine that the data comes from somewhere else. I mean, it could be from a database, it could be from a CSV file. Sometimes you would like to have like a version to like, you would like to dump it into an Excel file so you can actually scroll through it. And the built-in version in Pandas is to just call the toExcel method here. And then the friction that you have is basically you have to go into the folder where you just produced it and then open the output file, which is obviously fine, but then you may also need to like, get the full width of the column to make everything visible again. And then it's just sometimes convenient to scroll through the data, maybe to apply some conditional formatting, some filtering. If anything, then Excel may be a good tabular data viewer if you don't use it for anything else. Now, let me just go back to the notebook here. If you do that, so I mean, until now we have up until now we have used the reader and writer packages. Again, Pandas, I believe OpenPyXL or XLSX writer, whatever you have on your system to write this file. But in terms of like, if you do some interactive analysis in a Jupyter Notebook and would like to quickly check your data in an Excel spreadsheet, then there may be an easier way to do that, which is the XLWings view function. And the XLWings view function here basically opens up an Excel spreadsheet and just pastes whatever, pretty much whatever you throw at it. So it could be a list, it could be a dictionary, it can be whatever type of numbers, and it just throws it into a new Excel file at the top left corner. It does, do the auto fitting on the column. So takes a bit away the burden of manually looking for the produced Excel file and manually kind of formatting things in Excel. So that's a very easy way to interact with Excel from your Jupyter Notebook. From what I see, a lot of people use that when they do research. Now, the last 3 cells here are basically just here to give you a quick high-level overview of how Excel Wings works in terms of the regular API, because the view function is basically just a quick and dirty way to visualize data in Excel. But you can actually kind of remote control Excel by really just instantiating here a book, an object here, and then you can access the Excel object model pretty much the way that VBA offers it, but in a Pythonic syntax. So the same as before, you can just basically assign your Pandas data frame to whatever top left cell, and then that will write out the numbers here. You could obviously call the autofit then on your end, or just interact with it in here. And then to read it back, you do have basically the same capabilities. So you have the option here to use some option parameters, and this allows you to tell Excel Wings to deliver you the data back as a Pandas data frame. And this pretty much gives you, puts you back to the state where we started, and you're left again with that data frame in your Jupyter Notebook. Obviously, you don't have to use a Jupyter Notebook. Any other Python environment that you are using will obviously work equally well. So that's really just to give you kind of an introduction of how do reader and writer packages, as we use them through Pandas, and how do Excel Wings on the other side, how do they differ and how do they work. All right, so that's pretty much for the first part, for that interactive use. And then we can continue with something I personally find very useful, which is what I call static unit tests. Unit tests basically on static files using OpenPyXL. And I'm going to show you this directly in the browser. And so the idea here is really that you start tracking an Excel file in your Git system. And the good thing about Git systems these days is that they deliver easy access to some continuous integration pipelines. And in the case of GitHub here, we do have the GitHub Actions. And so all you need to do to be able to automatically run some tests when you commit a new version of your Excel spreadsheet is to write a small function here, a small test. And I'm actually running this with PyTest here. Let me try to make this a little bit bigger. And so all we do here is we open the Excel file, or basically we run through all the Excel files which are part of this repository. We open them using OpenPyXL, and then we basically just go through all the values and check if there is a reference error. So often when people work or refactor an Excel workbook, they introduce issues. And one of the most famous one is definitely the reference error, which happens when you delete an Excel cell that another cell basically points to or uses in a calculation. And so depending on what you do, it might be far out of sight and can cause some serious miscalculation of the rest of your workbook. So it's always good to be sure that there are no reference errors here in your test. And then the other thing is really we trigger that test with a simple workflow. It's literally a couple of lines of code which just install Python, and then in the end run PyTest on the code that we've just seen before, and that's pretty much it. So I've made already here 2 commits. And you can see the first one has the green check mark, so everything is fine. And the second one then basically has a failed test. And then you can look into the details here, and the test result will basically tell you that you do have a sheet which has reference errors in your sales transactions Excel file. And this then basically means, okay, well, you have to go back and fix it as usual. But that's exactly where GitHub then starts to show some boundaries, some limits. And as you can see, usually if this was code, if this was a failing unit test in your Python code, you could just click on it and then maybe see, okay, what happened basically in the last commit, right? So you would basically go in here and see, okay, what happened, but that's all I get from Git. And that's exactly why we built the other tool, which is called Excel Trail, which basically fills in the blanks here. And so I'm going to quickly show you how this works and basically takes it off where GitHub leaves. And so we can, add GitHub repositories to be synchronized by Excel Trail, or you can also create your own repositories. But in this case, I'm using the same repository here. So we do have, again, our sales transaction. We do have, again, our last commit. But in that case, we can already tell here, you can see that it has 2 sheets. And when I click on basically the change message, you can all of a sudden see what happened in that sheet. And you can basically see down here that, well, I deleted the cell here, which then on the second sheet introduced indeed this reference error. And so to get this into more perspective, you can always click on the context here, which gives you, again, basically the sheet view, and you can look at the cell in more detail and really, know exactly where that error happened. You can go back to your local version of the Excel file, fix the error, and then commit it. And while we are at, looking at the user interface of Excel Trail, and since this is a developers meetup, I would like to quickly say a few words about basically the tech stack that we use for Excel Trail. So on the back end, quite obviously, we use mostly Python. We do use a bit of .NET Core for some parts of it, but it's mostly Python. And then on the front end, we use a Vue.js front end. And the view you're just looking at right now, what looks like Excel and kind of behaves like Excel, is the hands-on table spreadsheet control in that instance. All right, so that's pretty much the second demo. So an easy way to use a reader package to get into your spreadsheets and do a few easy and static tests. Now, switching this over, kind of taking the next step and using Excel Wings instead of a reader package to do the tests can give you a bit more possibilities. And for this, I have prepared this sample here. And then let me see, here I do have written another few PyTests. And I think they are here. So I have made 2 tests, and the first one here is using the spreadsheet. So the spreadsheet is a classic spreadsheet, like, a budget spreadsheet. Like the first cell in here is always basically the last month's ending balance, and then you have a few inflows and a few outflows, and then it's the year end with the ending balance. And so to test, an easy test to make sure that this is always okay would just be to set, an initial value at the beginning, then put in some inflows here. I set them all to 10. I set outflows all to 5, so we have a net 5. inflows per month, which means on a 12-month basis, then we know if we start at 100, we know that this cell here has to be 160. And that's exactly what I test in this cell test. And then I have another thing that I'm testing, which is the, let me find the correct one here. Yeah, so which is I have a VBA function in this tool, and the VBA function is just a dummy function, so it's a sum between two inputs. And to write a unit test about that, it's also as simple as you can think about. So you literally just take basically the Excel Wings capability of mapping this macro to a Python function, if you want so, and then you just call that Python function, which in reality just basically executes the VBA in the backend. And again, you can just use standard Python unit tests to get some better feeling about what's going on. So let's just quickly test this in action. All I need to do is execute PyTest in here, and this will then run these two tests, and they pass. So we're good there. And now if we would introduce, let's say, a multiplication here on the VBA part, and maybe a hard-coded value somewhere in between the cell, and then run this test again, then we will instantly see that well, we've introduced errors, and yeah, it's just standard unit testing now. We can leverage all the infrastructure that we have from Python, so that's pretty much awesome. If you need to kind of, if your business users are using Excel spreadsheets, then that's a very simple way to get it under control. Or maybe even like if you migrate an Excel workbook into, let's say, a Python code base, then that would actually make sense to have a series of unit tests that run both on kind of the legacy Excel tool and then on the new implementation in Python. And you can compare those unit tests if they really behave the same in the legacy and the new system. So a very easy way to do that. If you wanted to, the thing about this approach is if you wanted to automate this on a CI level on Git, it is a bit more complex because you would indeed have to have a server with Excel installed. So for that purposes, the version I showed previously, the one with the static tests by just using a reader library, definitely makes things a lot easier. Okay, so I believe I have another like 4.5 minutes left on this talk, and probably won't make it to all of the demos here, but probably the next, or maybe 4 and 5 I can still do. And these are all, by the way, these are all covered by using the open source version of Excel Wings. So one of the things you can leverage when you use Excel and Excel Wings together is you can write user-defined functions in Python. And to do that, you literally just need to basically, let me just change that here, write a function in Python, which has a function decorator here. And then you can also, again, let Excel Wings do the conversion for you. So basically you can say, okay, whatever you put into the function shall arrive as a Pandas data frame on the side of Python. And then, you know, it kind of can boil down to like a one-line Python function, which just leverages the fact that Pandas pretty much gives you a lot of functionality that you will never ever have at your disposal in Excel, which, for example, is just, you know, a correlation matrix. So you have to write .core and you are pretty much done. Whereas in Excel, if you wanted to have a correlation matrix across a big data set, it doesn't really give you a function for that. It only gives you a function for well, two time series, let's say, and you can get the correlation for these two data sets, but not for like a big a bit matrix of data. So to demonstrate that to you, after importing these functions, you will have them available here. And so instead of the built-in correlation, which only accepts 2 data sets, I can use the correlation function here that I did in Python, and I can press OK, well, enter, and this gives me here the full correlation matrix. By the way, these are like returns from S&P, from some stock index. But it doesn't really matter. I mean, it could be weather data, it could be, anything. But it's just so simple then to get the correlation matrix here with a simple formula. And then if you wanted to go further, you could even use some way to basically get that correlation information and produce a matplotlib chart in Excel. So this here, again, you will find the source on GitHub is really just using some matplotlib function and pastes the picture then in Excel. And the fun part about that is that if you change your underlying data, the chart updates itself also on the side of Python. And I believe I'm kind of running out of time, but I hope that these few demos gave you a little, kind of a feeling of what you can do with Python and Excel in the combination. Your business users, if you are working with business users, they will most likely always use Excel at some end of their work. So if you give them Excel if you give them Python together with one of the packages I was showing you today, you can make their lives easier by automating stuff. You can take out the risk in their work. And you can also use Python really nicely to do some automated testing and applying best practices to the world of Excel. And I guess with that, I would love to wrap up my talk, to stay within the time and take some questions if you have any.
Hi, I'm back.
Hi.
Only actually one question. There was another, but you answered during your speech. So the one left is how to perform live update.
Okay. Okay. So is that a question in terms of real-time data formulas, maybe?
I can see that the author is writing something.
Okay.
So let's have a second. Yep, real time.
Okay. So currently, Excellinks, we don't support that yet. So there's an Excel function which is called RTD, real-time data, and it allows you to subscribe to basically a real-time data feed, which pushes data to your Excel cell. We don't currently provide that. Pixel, the commercial alternative, does provide that. We do have it on our list of things. So, check back in a few months and then maybe we have that implemented. What you can do at any point in time, though, is always, you can always have basically a Python server that you run from Python directly, and which just checks a cell. If it changes, it writes an update to another cell. So that is always possible. It just means that you're not operating with formulas, but you're really just basically starting an independent Python process, which then writes data as they arrive directly to Excel. So that is always possible. It's a bit less beautiful in terms, I guess, from a user's perspective in Excel. But if you need something today, then that would work too.
Okay, I can see author is still writing. He wrote, you get chat in the bottom on the right. You can see this question actually. Rat Zaleski wrote,
yes,
real-time data, I'm using Plotly. Oh.
Okay, so maybe the question was with regards to specifically the chart. So for now, the charts, they don't allow you to basically update them in real time once they are in Excel. So this is really thought to be for static plots, as they are, you know, like stupid pictures only. For live updates of charts, I don't have a solution for, you know, like a proper like Excel integration. So for that part, I guess it's easier to stay in a Jupyter notebook probably. But I mean, I can also, you know, I'm happy to take it up also after my part of the speak. So Rad, if you know, if that doesn't answer your question, please feel free to send me an email after the presentation. So I will definitely be happy to answer and follow up there. Okay,
Felix, can you write down your email in the chat window?
Yes, absolutely.
Great. Okay, so thank you for the speech. And I'm going to introduce next speaker. Thank you very much.